In December 1998, NASA launched the Mars Climate Orbiter, a state-of-the-art $125 million satellite designed to track Martian weather and act as a communications relay for future rovers. After nearly 10 months and 416 million miles of space travel, the orbiter finally arrived at the Red Planet in September 1999. Scientists back on Earth held their breath as the spacecraft fired its main engine to slip into orbit around Mars. As planned, the satellite passed behind the planet, temporarily losing radio contact with mission control. The team waited for the signal to re-emerge. Minutes ticked by. 10 minutes, 20 minutes, nothing. Just static. The $125 million spacecraft had vanished into thin air. NASA quickly launched an investigation to figure out what went wrong. Did an engine explode? Did an asteroid strike the satellite? The real answer turned out to be far more embarrassing. The spacecraft hadn't vanished. It had crashed straight into the Martian atmosphere and disintegrated into a ball of fire. And the cause wasn't a mechanical breakdown or a software virus. It was a single, ridiculous human error, a unit translation mix-up. To navigate through deep space, ground control computer systems need to calculate small thruster firings that adjust the spacecraft's trajectory. Two separate engineering teams were working on these calculations. The first team at Lockheed Martin built the ground-based software that calculated the total thruster force required. But because Lockheed was located in the United States, their software calculated this force in pounds force, an Imperial unit of measurement. The second team, at NASA's Jet Propulsion Laboratory, received this data file. But JPL software was designed under the International Standard Metric System, assuming the incoming numbers were in newtons. Here's the fatal problem. 1 pound force equals 4.45 newtons. Every single time Lockheed's software output a thrust value, NASA's computers interpreted that number as being 4.5 times weaker than it actually was. Over the course of a 10-month journey across the solar system, these tiny mathematical discrepancies kept piling up. NASA thought the orbiter was gliding safely through space at an altitude of 140 to 150 kilometers above the surface of Mars, well clear of the dense atmosphere. In reality, the trajectory calculations were wildly wrong. The spacecraft dipped down to an altitude of just 57 kilometers. At that dangerously low altitude, the thin Martian air hit the spacecraft like a brick wall. Atmospheric drag ripped off its solar panels, and the extreme friction incinerated the $125 million orbiter in seconds. How could world-class rocket scientists miss such a fundamental mistake? Simple. Communication gaps. The software interfaces between the two teams hadn't been double-checked for unit compliance, and early warning signs during the mission were brushed aside as minor discrepancies. The loss of the Mars Climate Orbiter became one of the most famous, expensive engineering facepalms in scientific history. It led NASA to overhaul its software quality assurance protocols and enforce strict, mandatory unit checks across all missions. The takeaway? Whether you're building a billion-dollar interplanetary spacecraft or just solving a middle school physics problem, always check your units.